To finish this section about the fundamentals of position vectors, I'm going to hit you in the head with something that I already talked about, but I think it's very important to insist on. So the data that we get and set in the node editors, they have a context. So we have to grasp that in order to not try to not frustrate our expectations. So here I've drawn several vectors on top of this mesh, so I can kind of talk about that, talk about the context of data, so that it's not something that is as frustrating, hopefully. Of course, these things only can be overcome with experience. So here in the GL tab, make sure you have transparency on, so you can see the vectors that are inside the mesh, and also make sure you have Studio Live on. So in orange, you can see some little vectors that come from the object to the vertices. So they are rooted, their context is the object, and they point and go up to the position of the vertices. In this blue, this dark blue, we have the same positions, the vertex positions, but in the context of the world. So that's why I have here vertex position world, vertex position local. And so you can see that they are different. In magenta and in green, we have the normals, but since they are both in context now, we cannot see them. So they are overlapping at the moment. Then in this light blue and yellow, we have the position of the object relative to the parent and the position of the object relative to the world context. And so this is all sort of data that we get from Node. So here I have the object spot and I have the world spot. I have here the position and I have the world position. And so of course it helps to grasp how the data looks like in a bit of an abstraction exercise to better understand how, if we are going to create relationships between positions, we need to make sure that those positions are in the context that we expect them to be, and that when we output them in the node editor, be in the displacement, be in the nodal motion, that the context or in which that data is going to be applied also matches our expectations. So for example, I have here that the spot info node is used in different ways for the displacement node editor and the surface node editor. So in the displacement node editor, the object spot is the vertex position, just like you see it in Lightwave Modeler. So the data that you're going to get is just like if you would open your model in Modeler, and those are the positions that you get out of it. And the surface node editor is not just the vertex position, it's the surface spots position. So it's the polygons, all the spots that cover the surface and are rendered. And so in the object spot, you're going to have the surface spot position, just like you have when you open the model in Modeler. In the world spot is a bit trickier, especially in the displacement node editor, because it's not going to be the same thing as it is in the surface node editor. So in the surface node editor, those surface spots are evaluated, the data that comes from the world spot is after everything happened. So the mesh has already been morphed, formed by bones, has already been moved. So everything already has happened when the surface goes into rendering. In displacement, not so much. You might want to move an object and then displace it, or displace an object and then move it. So you have this drop down here that allows you to choose the order. And so that affects what the world spot is. And it's going to be dependent on this option, both in the world spot data and also on the output of the displacement node editor. So also going to be dependent on whatever you have selected here. So let's look at an example of data without context. At times I might draw some coordinate axes just so that I can talk about data that I'm seeing in the viewport without the context, because, well, sometimes we see things in the viewport. I see this vertex normal, of course, at the vertex. Doesn't make much sense to look at it without the vertex, because then I don't know which vertex it is from. So at times we see things in the viewport in the context they are in. For example, let's say I have this vertex in context, but if I would actually be able to see it without context, maybe I would see that the vector actually looks like this. And so I would be trying to manipulate data like I see in the viewport, but the data that I'm actually manipulating looks like this, so my expectations don't match. Let's look at something that happens. So here I have this switch that here I have the data in context. So I see the vertex normal coming from the vertex. I see the position relative to the parent coming from the parent. But as I put the switch here, now you can see things without their context. So now I can see the positions, the object positions of the vertices are here, just like I would see them in Modeler, but the world positions and the world position of the object is still the same when I change this, because I've put everything into a single context, the world context, and so that's how things look like when that's why I sometimes make a little coordinate axis and I call it data, just so that I know this is how data looks like. It's not exactly that I'm creating a relationship with the world space. It's just that I want to look at how things are without being deformed, because I have these positions in Modeler, but after I move the object around and I rotate it and I scale it, these are going to change, and I'm going to grasp them as coming from this context of the object, and I lose my sight of how the data actually is. So even if I rotate this object, you can see that these orange vectors are not changing. So the vertex local position or object spot does not change regardless of whatever I do to the mesh, unlike, for example, the world position, which of course updates as I change my object. The same goes for the object position relative to the parent. So here I have this yellow vector that if I put it in context, you can see that it seems that comes from here to here. And of course, if I rotate this even more, it's going to become more obvious that when I remove the context by drawing that vector, that it's going to look radically different from what I see in here. So if I move, let's say if I move this this way, or actually this way, and I rotate like this, so I can see the vector looking like this, the data of it looks like this, but when I put it in context, it kind of goes the other way around. So this might trick me, and that's the purpose of this demo, that you can kind of be prepared that sometimes you might see things in the viewport, but the actual data that you get from the nodes might look a bit different. And so this is here you can see, for example, now the magenta and the green normals. So in the green normals are the ones that you can see in Modeler. So even though that I rotate this, etc., the green ones, they stay the same because they are just relative to the mesh without any transformation. The magenta ones are after the mesh is transformed. And so of course you can see that here you cannot understand which point is the normal from, so it's kind of a bit hard. That's why of course we prefer to have things in context, because it's easier to understand, okay, this normal is from here, etc. But to grasp the data, sometimes it works against us. So let's look into another some other examples. So here I have this object, and it has several things done to it. So let me see here. So I have it, let's see, it's the morph one. Okay, I have this morph on it. It has some bones, and you can check, I can prove to you that it has bones by, let me just reset this here. Okay, so I can prove it has bones by simply turning off bones. So if I come here to setup bones off, right now you can see that, you can see this little bone here. So it has some bones deforming it. And I want to basically talk about this point of evaluation for the world spot. So the world spot is not like simply like I shown in here, the position in the case of the displacement. It's not just the position of the vertex relative to the world. It's going to depend. Basically, it might mean different things depending on what you choose in the node displacement order. So let's look into that. So I have this object with three things going on. The object is morphed. The object has bones deforming it, and the object is moved, so it's away from the origin. It's not sitting at the origin anymore. And so when I come here to the node displacement, let me put this here. When I come here to the nodal displacement, I'm going to subtract the object spot, so the positions that I have in Modeler, so to say, by the positions of the world spot, meaning the current positions that they have in the current evaluation, which is going to depend on this drop down. So after morphing does nothing, but if I put before bones, now the morph got killed. And if I put before local displacement, now the bones got killed, so I don't see the bone deformation. And if I put before world displacement, now I don't even see the movement that I gave to the object, as you can see. So this shows that the same port world spot is going to give me different information depending on the displacement order I choose. You're going to have similar thing here with subdivision order. So this is something to pay attention. Now let's look into another thing, which is having an object copying another object, an identical object point positions. So I'm going to bring this object here, this grid, and I'm going to put it in wireframe. It's identical to this object here, and what I'm going to use to copy the point positions is I'm going to use two Denis Pontonnier nodes. The nearest point, which will give me the IDs, and so I select the object itself. It's the grid evaluation point 2. That's what I have here. And with those IDs, I'm going to pick the positions of grid evaluation 1, which is this one here. So can I just plug this in here? Nope, because I need to subtract the positions. So if you remember, the displacement node editor is basically a position that is going to be added. So I need to make a delta. So let me bring the spot info node and let me bring a subtract. So if I do this, I just get the same thing because the object position or the object spot is just like in Modeler. So, nothing is being done. But if I put the world spot in here and in here, you can see that now the object, this mesh follows the other one. And it doesn't matter what's the thing I put in here for the object itself, but you can see, let me put this, let's say 1, 2. Okay, so it doesn't matter what I change on the object where I'm applying this. As you can see, after morphing, before bones, before local displacement, that doesn't change because this evaluation here is relative to the object itself. So basically, when I put world spot here, since I haven't moved the object, it's going to be the same as putting object spot. So it's not going to change because I did not move this object. I did not transform it in any way. So the object spot and the world spot will produce the same thing. Now, when I want to start to move this object, then I'll have to take that into account. So for example, if I want to move it, rotate it, etc., then I need to put the world spot in there. And now, even though regardless of what I do here to this object, if I move it, rotate it, scale it, it's going to stick to the positions of the other mesh. So this is something to take into account, and this doesn't affect, this just does affect the evaluation of the world spot. It doesn't affect the evaluation of the world position of the other mesh, because this is just reading the end of the stack of the other mesh. So this world position, when it is about another mesh, then not the mesh itself, it's going to read the world positions after deformation, after bones, after displacement, after morphs, after moving the object, etc. So that's why it's going to be not affected by the nodal displacement order. But still, the world spot for the mesh itself, it is affected by this drop down. So I hope this was a bit clarifying. This is something, like I said, for me it was a bit tricky when I started to deal with the spot info node and wanting to create relationships between positions, and sometimes the context was not correct, and that would frustrate me a lot. So hopefully this, of course, experience is going to show you what you have to do, but I hope this is a solid foundation so that you can do better guesses. Also, you might want to take a look at that diagram about the context of data and test it out by yourself.